What the hell is univac assembly? What is this? The Universal Automatic Computer was the first general purpose electronic digital computer designed for business applications produced in the US. No, bro. If you did this, you would most certainly be like if this is what you're talking about, you're probably the best programmer out of all of us. Univac assembly. I don't know if this is. I don't actually think this is right. Assembler Univac assembler programmers reference. What the heck? What have you done? Univac Sperry Rand Corporation. Hey, what's up, Lawler? How you doing? Good to see you. Embrace antiquity, revert to 4chan. Yeah, after that Casey video with Prime, yeah. You would need a punch tape drive. They're hard to buy, but it would be fun. Vacuum tubes, Rand Corp. Interesting. No way. The assembly program recognizes the set of mnemonic instructions representing the machine code instructions listed in Appendix A of this manual. Damn, the format of these machine code instructions is as follows. Function, yeah, indicates partial word designator or minor function code. A indicates the control register or input output. X indicates the index register. H indicates index modification. I indicates indirect addressing, and U indicates the address field. Damn. Yeah, Lawler. Doing well, man. Thanks. Glad you're all right. Is that a 35-bit word? Or you could use EJS, yeah, or 36. I don't know. We're deep into old school punch card programming, Lawler. You probably walked in at the wrong time. Index registers, arithmetic registers, R registers, partial word designation. Yeah, it's like showing you which bits. Yeah, like you'd have, yeah, you have like your, yeah, label, operation, and operand. And you'd have to make sure that your, yeah, you'd essentially have to make sure your punch cards had the right wait, wait. Subscripted labels. The assembler permits usage of subscripted labels. A subscript may be any legitimate assembler item, an expression, or another subscripted label. A label may not be used as its own subscript. A subscript is enclosed in parentheses immediately following the label, with no intervening spaces between the label and subscript. If more than one subscript is used, each subscript is separated by a comma. A series of subscripts is enclosed in parentheses. Examples: L3, L41. I guess this would be it looks like that thing was showing you which bits mean which thing. Yeah. You've heard of punch cards. I haven't we all. I learned assembly 68K once. I could build a calculator account seconds from 1970. Nice. Then you're good, Battle. Then you're good. So I guess this would be like functions perhaps, and then like sub functions inside of sub functions. Um, location counter, data word generator. Holy crap. Octal. Let's go. Octal. Here, octal values, decimal values, alphabetic items, line items, and it'll tell you exactly. Damn. Oh, hey, Den. Good to see you. It's been a while, man. Thanks for the raid. I appreciate it. I hope you had a good stream, Den. Let's yeah, we'll make sure we'll give a shout out to Den. Yeah, I mean, you caught us looking at this. Caught us red-handed, Den. Somebody, some jerk in chat brought up the assembly language for the VAC system, and now we're here. Subscriptive labels made things so much easier, like Tailwind CSS for layout. Battle, you bastard. Binary, floating. Yeah, jerk would be me. That's right. You just started streaming again? Well, I hope it's been going well, Dan. I touched assembly last time like 25 years ago. Yeah. Yeah, it's crazy. Like, could you imagine? It procedures and functions, okay? A procedure sample must begin with a proc directive and end with an end directive. The proc and end directives are the delineators of the procedure. The format of the proc directive is as follows: label proc operand, all right? And so label proc operand, and then the end directive is we're done. And then you can reference it. Hot damn. Could you imagine programming like this? Yes, it is an anti-tailwind crowd, absolutely. I mean, not like in all cases, but in most cases. This is a fancy assembler, yeah. An anti-everything crowd. A rewrite of UNH and punch cards, yeah. Oh, that might actually be fun. This seems like the kind of thing C was invented to replace. It does, right? Because you do have a lot of um you do have a lot of stuff that would easily be hoisted up into the C lang space out of here. Like let me see. Implied or logical nesting, right? So they even have a procedure which is called upon within another is an implied procedure if the procedure referenced is not nested physically within another procedure. Only the call line is located within the higher procedure. Implied nesting may be nested at a maximum of 62 levels. That's actually like, that's crazy. Actually, 62 levels of nesting? That's not bad, yo. So you'd call it, you'd start another procedure, then you'd end. Then you'd go to the next procedure and it would start a nested procedure. Then it would start yet another nested procedure, and then you'd go into that procedure XY and you'd end that. And then you'd have to end WZ, and then you'd have to go back to WZ, and then you'd have to end AB. The proc sample must appear physically before its reference in the main program. Forward declarations. Like C, forward declare your procedures in this. Like C, you can't use a procedure you have not yet declared or defined. If a go statement transfers control to an entrance label of another procedure, this is not considered nesting, but is a lateral transfer and does not change levels. What? They had go jumps? had go jumping. Um, okay, levels of procedures with a hierarchy. Yeah, so you'd start the there you go. You'd start the main program. So here's C int main. Circuit boards that were sent into space were hand woven NASA contracted textile workers. That's crazy. End main. Here's a start of AB, and then you jump in. And so this is I guess this is what they mean by lateral. Maybe. Well, I don't know about that actually. And both of these can call XY, but at different nested levels. Yeah, yeah. An asterisk immediately following a label makes that label available for reference from a procedure one level higher. What? A label at the main program level having an asterisk is externalized and may be referenced by any other program? What sorcery is this? Below is a diagrammatic representation of labels appearing in procedures. Start the main program, call one major. Major has a star, and so it's a proc. Yeah, okay, laugh. Check it. An asterisk immediately following a label makes that label available for reference from a procedure one level higher. A label at the main program level having an asterisk is externalized and may be referenced by any other program. A label in a nested procedure may be referenced by one procedure level higher for each asterisk appended to the label. Yeah, yeah. Dark magic. Yeah. So label star is kind of like export. Yes, exactly. And not just that. A label in a nested procedure may be referenced by one procedure level higher for each asterisk appended to the label. Yeah, it's like early import, right? Like, right? And so major proc goes up one, mid proc goes up one, but M1A, yeah, macros, M1A, M1B, because they have double triple asterisk, are available higher up the chain, as many asterisks as needed to go up that many number of chains. As a rule, lower level labels are available only after a call is made on the proc in which that label appears. See, and so M1B has triple stars, and so it's available to all of procs and the main program, right? Not here, sorry, here. Yeah, yeah, yeah. And yeah. That's crazy, bro. Bro, what is this? If spaghetti lasagna, declaration spaghetti was mind fudge, but it was efficient. Yeah, I mean, imagine how fast this thing ran. And that's back when you had to account for every bit. Storage hardware was prohibitively expensive. No kidding. Check this out. Look at this. Look at this. The user is cautioned. Guys, hang on. We're putting the game on hold. Hang on. This is bonkers. Yeah, kids these days, yeah? The user is cautioned against basing the generation of code within a procedure sample on a condition involving a forward reference. Have a good night, Lawler. Consider a hypothetical move procedure. The programmer may check if the move from and move to addresses are the same. On the first pass through the source data, the labels of the from and to areas may or may not have been defined. On the second pass of the assembler, the labels will have been defined. The values reached on each pass of the assembler can be different. If the procedure sample does choose an error exit on pass 1, that is no generation of code, and does produce code on pass 2, the labels following the call on the sample are assigned a location counter value on pass 1 that is different in pass 2. The result is a multiple definition of those labels. Whenever the assembler gets a different line count on the first or second pass, multiple definitions of succeeding labels occur, and de-error flag is set. The user is admonished to take great care when using forward references. What? What is this? This is crazy. This is bonkers. If the card stack submitted into the take up was out of order, all your purgatory time was exonerated. Yeah, this is pre-structured programming. This kind of thing is exactly why structured programming became a thing. That's hierarchy of label definition. Warning labels, bros. We're only halfway through. Complex procedures. Should we? Should we read complex procedures? The do directive. Do. The do directive in the assembler is a powerful tool which, when used within procedures, provides great flexibility and power. The format of a do line is label 1, do, expression, label 2, operation, operand. The comma divides the do line in two parts, the determinant, label 1 do expression, and the do item, label 2 operation operand. The expression following the do directive determines how many times the do item is generated. Label 1 is optional. If used, label 1 serves as a counter reference, reflecting the current number of times the do item has been executed. What? The do item may be any symbolic line of coding. The do item may contain another do directive nested down to 8 levels. Example of a simple do. Number. Do, a do, 5, a. As each a plus a is generated, the value of the label a is increased by +1 until 5 do items are generated. This is a freaking, we figured out a for loop in assembler code. In punch card. What? We've got a for loop. You guys are staring at a for loop. All expressions appearing in the determinant must be defined. All undefined expressions are 0 until they are defined. If, for example, the determinant a do tag is written and tag has not been defined, the assembler reads a do 0. There's default values, bros. A line count is not assigned, and the do is not executed. The do count must be defined before the do directive is encountered. Punch, hey, Ant, how's it going, man? Back in the day when we had to assemble code by atoms. There's conditional do, bros. Conditional do. Hang on. I gotta have some coffee for this. Hang on. Have you heard of Vanilla JS web components? I sure have, ALS. I sure have. Yeah, imagine spilling all the cards on the floor. Okay, so the operators, less than, equals, greater than, are relational operators and generate the value 0 or 1. If the relationship between two expressions is true, the value of the expression is 1. If false, the value is 0. You just saw Vanilla.js web components for the first time? Bro, you need to dig into that. Web components are really good, a lot better than people make them out to be. They can be annoying, um, and you know, they don't solve every problem, but yeah, it's deprecated. There's web components still exist today. Yeah, they're still in the browser. Look them up. They're more powerful than you'd think. That's why Baby Jesus gave us IC surface chips. Yeah. The expressions employed in the determinant have, to this point, been simple. A more complex expression would be a conditional to. Sorry, I meant my projects I work with are deprecated. Oh, I see. Got it. Yeah. Hang on, folks. Hang on. Let me just make sure. Okay. I'm sure if I learn web components, try to use it at work, I would have to delete the code and write what they're used. Yeah, probably. Yeah. Okay, so Q is the label. Do A equals 1. So you set A to 1, and then you add 4 to minor. If A is 1, then by substitution, 1 equals 1. Since the relation is true, the value 1 is substituted for the expression. The result is equivalent to Q do 1, add 4 to minor. The do item would be executed once. Right, because 1 equals 1. Right, and so you'd only do this one time. The following move procedure illustrates the conditional do. The procedure will move data from one area to another or initialize any given area with any given constant. Call line from move proc has 5 fields. The 5th field has 2 subfields. What the hell is this? Move 12 words to right from input to. Bro. Check this out. Check it out. Can can anybody even read this? Is it even possible to read this? I don't know if it's possible. Hey Mackle72, thanks for the follow just now. I appreciate it. I, I I'm not sure anyone can read this. Move proc, move. Okay, so we have a star, which means that this is available to the parent. So name 1, that's the operation. 0 is name 0. Much easier to read than APL or yeah. Hey Mackle, what's up, man? How you doing? You caught us at a weird time. Usually I'm programming a game, but we just got into assembler code. Here, Mackle. Normally, just real quick, just so you know what I'm doing. Normally, I'm writing a game in C, compiled to WebAssembly and rendered on the browser with Vanilla.js, CSS, and DOM elements. No Canvas, no WebGPU, no WebGL, anything like that. This is what I've been working on today. Vanilla C, like no structs, no pointers, like hard mode. Just to kind of prove a point that um, there's a lot you can do with very little, and we seem to have forgotten that in the industry. So I'm just leading by example, trying to do something crazy here with a video game. But then we got into this assembler stuff, and now we're here right now. LA A0 1 move 3 1. Do move 3 2 greater than 0. Not any assembler, univac no less. I used to use a univac. Damn, you've been around for a while then, right? AA120 MV3214. I'm starting to get lost right around here. I'm not gonna lie. AA1 move 00 move 5 1. Do move 5 2 greater than 0. AA13. Oh, okay. Wait. 0 move 5 to 14. It's once you reach the do lines 5 and 7, check to see if a parameter was supplied. In this case, the parameter specifies an index. The procedure is checking to see if the address was indexed. If it was, it would add the value to the index to the address to achieve the proper effective address. The paraform MV01 references the subfield attached to the operation. Okay, that does help explain that a bit better. Note that unspecified subfields of a given field are automatically assigned a value of 0. In this example, the third field right is such a case. Right. In such a case, yeah, therefore, in line 5 of the coding, move 3 to greater 0 is false because lack of the subfield for right reduces the value to 0, and 0 is not greater than 0. Uh, Wait, what? Unspecified subfields of I see, because it's unspecified, right? And so it would collapse down to 0, and then when you do the 0 check here, it's like, well, I don't know what you're talking about, bro. And so what? Right? Yeah. Okay. And so the third field, 3 2, doesn't have a value, and so when you say what is in 3 2, this MV32 collapses down to 0 because there's no value in it. And then when you do 0 is greater than um, 0, nothing happens, right? Because 0 is not greater than 0, so nothing happens. But so you can see 3 1 has a value of 1 in it. That would, so if you switched this 3 2 to 3 1, it would run. Then the subsequent things would run. But because we don't set a value for 3 2, nope, we ain't coming down here, right? And so then you'd run to the next operation, and it would be 0 0. Whatever the value of 0 0 is would get put into 5 1. But do we set 5 2? So this wouldn't run either, would it? I've just confused myself. I'm actually not sure. What the hell? They have do arrays? This example cannot be executed. The value for E is initially 0, and the item array10 does not exist. If written as follows, however, E do 1, then do array1E greater than 0, A to 12, whatever this represents, min. This line of coding can be executed since array11 is referenced. Guys, I'm going to be honest. Seesaw calls what? I'm going to be honest. I'm a little lost. Uh, I'm a little lost. This should be basic. It should be basic, and I'm a little lost. Um, uh, Hang on. We're smart, right? Aren't we smart? We should be able to figure this out. C proc 4 saw name 2 LAC11120001 TLEC2131. Go to I. I is down here, referencing name, which I think is 2. Do C41, but I don't think 41 does anything, plus 3. Then we keep going. Name. Ear name 4. Saw C110001, which is an incomplete array, I guess. Call 1C, 16 cat, 17 dog times 43. Call 2 saw, 5, 16 cat, 17 dog, 43. Call 3 ear, 6, 7, and 16. Explanation. What is happening? Line 13 calls C proc. Right here. Okay, so 13 call C. And we go jump up here. The subfields in the operand field are C11. How? Where? Oh, I see. I didn't finish reading it because I'm a dummy. C11, C12, 21, 1 for 1. Okay, yeah, because they're set up here. The subfields refer to 16, cat, 17, dog, star 43 respectively. These values are substituted for corresponding paraforms in the procedure, and lines 3 and 4, lines 3 here and 4 become LA16, cat00, that's where that comes from, okay? And then TLE17 dog. TLE17 dog. C00 and C01 equal 0 since the entrance was not made at the name line. Lines 6 and 7 are not processed. Line 14 calls the saw proc the value C01, C, etc., etc. Refer to 5, 16, cat, 17, dog, and 43, respectively. The paraform C01 is 5 as 5 is the second subfield of the 0th value. C00 references the name line and its value is 2. Lines 3 and 4 become 16 cat 25, 17 dog. Lines 6 and 7 are not processed. Never happens because you never enter this. Line 15 calls the ear proc. This causes entrance at the name line labeled ear. C00 is 4, C01 is 6, C02 is 7, C11 is 16. Line 7 becomes SA1646. SA16, 4, and 6. Oh, I think I'm starting to get it. Right. The do statement generates no coding. Right. So it's function calls that, yeah, so down here, you're calling functions up here and you're passing parameters. And then if you pass in the correct values in the right format and structure, it will fill up essentially like an array of values which you can index. And then when you if ear was to work, for example, it would collapse the array values to the values you passed in when you made these calls, and then you could like read the values out. That holy crap. Come on, we have it so easy these days. Can you like imagine doing this? Like actually imagine that you had to do a simple function call like this, right? So it'd be like this would be kind of like the equivalent of something like uh we could just do it in C here. So it'd be like U32 C and it'd be like 4, right? And then you'd go I don't know, void saw and maybe like something along those lines. But imagine that you'd have to take a function like this and then you'd have to go like U32 param 1, U32, param 2, etc., whatever it is you want to do. And then you have to take each one and go C4 equals param 1, C or C0, whatever it is, right? And then you have to read it out. Well, what's wrong with just call and ret? Well, maybe it's just to demonstrate what you could do if you needed this level of complexity. This code can be referenced by the current procedure and AB procedure. I mean, now we're talking about code comments in punch cards. We're talking about code comments and punch cards. Seems like a nuts abstraction over ASM. Maybe you, I don't know. I don't know. Maybe you had to for like maybe this was required. Dear Lord. Maybe they had to do like backwards compatibility for some like I don't know. Like I'm not sure. What jQuery? jQuery mentioned $ plus two. PHP mentioned padding instructions, blank lines. Oh, this is crazy, yo. What have you done to me, Battle? This is kind of cool. And then we've got our appendix, which is probably full of all kinds of awesome stuff. Not gonna lie, it's science run amok. Yeah, it's fun to read though. Mnemonic with codes, similar error flags and messages. Yeah. Abort cannot read proc from drum. Imagine. Imagine. Can you imagine? Cannot read from drum. Bro, you're done. You're so done. It's over. If you cannot read proc from drum, it's over. Wow. Add exception like that to your game. Cannot read proc from drum. Yeah, I should. Sleuth card. What? Wait, what? Sleuth card? Bop internal. Wait, drum error on drum procedure read. Yeah, okay, okay. An end of file condition was detected on the source input file. This comment appears in the comment field of an end card supplied by the assembler. Processing continues, but the error exit will be used to terminate the assembly. Sleuth card. Write a drum memory emulator and use it. So crazy. Damn, that was actually a fun read. I just found a PDF for Sleuth. Did you? Um, what, laugh. You can't do this, bro. You can't do this. You can't make us go look at Sleuth. You can't do this to us. Um, I can just kind of close this. Why is this taking so long? Oh, it's the host. Yeah, it's not loading up. Uh, it loaded instantly for you. Maybe it's something on my end though. I don't know. Even on my other machine, it's doing the same thing. Let me try. No, not Chrome Remote Desktop. Yeah, yeah. What are you? Let's try this. Oh, there we go. Okay. I'm still on Bell Internet System. First edition. So what's sleuth here? Okay, programs, yeah. System flowchart. Source code goes through the sleuth assembler, library, corrections, listing, corrected source code, advent of code, clamp advent of code, load routine, run the program, redirect rocks, exec rocks, memory and IO allocation input. I'm not sure what this thing. It's so is it meant to fix issues? Tag, label, subfields, yeah, comments, numbers and symbols. Following the colon. It's the next big thing. It's just as esoteric. I'm not even sure what this is supposed to do. Oh, you know what this is? Bro, do you know what we're looking at right now? This is uh it's a linter. Yeah. It makes sure that you have structured your program correctly. Like you've used the right like words and stuff and structured it correctly. And it also lints against the hardware. Like it ensures that depending on what you're using, like depending on what you're going to operate this on, in this case the univac systems, it will lint whatever you're pumping in to say like, hey, this won't run. Check out page 5. It's a freaking linter, bro. General description. It's an advanced symbolic assembly system which provides the programmer with a powerful and efficient tool for writing programs for the 1107. It accepts instructions containing mnemonic function codes and designators and symbolic operand addresses and translates these instructions to an absolute or relative form ready for loading and execution. Sleuth is a two-pass assembly system. The first pass is devoted to merging corrections with the source code input, so it links your code, developing a dictionary of symbolic assignments, and doing a major portion of decoding each symbolic instruction. So a little bit of transpiling as well. The second pass uses the output of the first pass and the dictionary to complete every instruction. It produces the desired binary output, a listing, and a corrected source code if requested. A set of declarative functions is provided to instruct the assembler and the special details of assembly, which include definition and generation of macros. Bro, macros mentioned. Let's go. Insertion of library routines from a library tape, equation of symbols, protection against duplication of symbols, corrections to the source code, deletion of any predetermined set of instructions, which is primarily designed for but not limited to deletion of debugging aids at the completion of code checking. So it will literally do like if you have a debugger aid, this guy will just like rip it out for you. So it's not even just a linter; it's like a multifaceted thing that will literally go through your code and like pre-compile, land, check for like ensuring that you've structured everything correctly, and then like remove debugging operations if you have them. Get everything ready. Like it's crazy. Yeah, if def debug. Three types of binary output can be produced by the assembler, of which two are in relocatable binary form or relative object code, that's ROC. Absolute output, AOC, can also be obtained for a completely defined program. Programs which perform input-output operations internally and which are to be run serially may be in the direct I/O form of ROC, direct ROC. Relocation or reassignment of addresses and modification of peripheral facilities is possible at load time. That's crazy. Damn. So in some cases, if you have a well-formed program that is like essentially complete, it can just check that for that. It can check, like, it can produce that, like, an absolute version of that complete program. But in other cases where you might need to do processing as part of the program, and so it's technically not complete because you have to run operations to complete it, it will also check for that. But then collapse that program down to like an executable that you can run wherever you need to run. Yeah, Battle, this is all your fault. Does this mean that there was a machine that took in a card and had an output with cards and a hole puncher? That's what it looks like. Yeah, because if you look at it, you're going to pump in the source code. You're going to pump in any corrections that you might have, which might actually come out of the sleuth assembler. By the way, sometimes you might have like a set of corrections that need to be that this it's like a self-feeding system. So you might run source code and library, pump it into sleuth assembler. The linter portion might be like, hey, no, you haven't structured this correctly. You need to make these corrections. You create the corrections, you pump it in with your original, so you don't have to go recreate these two things. Because imagine having to recreate the source code and the library punch cards in order to re-up them, right? And so essentially, when you're done, it will compile everything into the corrected source code, and then it will figure out, is this a complete program, is this a portable incomplete program, or is this whatever the exact rock, I'm not entirely sure what that means, right? And it'll just pump you out whatever it is you need, and then you just go pump that into the machine, and run it. I think probably at a conveyor belt. Yeah, that's crazy. That's also very cool. That is also very, very cool. Hey, Cyber Crystal City. Sorry I missed your follow from like 15 minutes ago. I appreciate it. Yeah. Damn. That's so cool. Battle. Never do that again. Never, ever, ever bring up esoteric, really cool stuff like that ever again. Don't ever do it again. Never. Because if you do, we might spend an entire hour reading the documentation on old school assembler stuff. But just imagine if you had to do this. Just imagine. Just imagine yourself. The drum fails and you get that drum exception error, and then you have to go figure out what the hell happened. Just imagine. You're going to do it? Yeah. What are you going to do, ALS? Eh, I imagine the job security if you programmed this. I know. I know. You're probably employable to this day. Um, there is a part of me that wonders. They even have const, yeah. There is a part of me that wonders if they have variable substitutions. Do they literally have regex? Wait, do they have regex, or are those just dividers? Oh, they're just dividers. Okay. Okay. Yeah. They're just dividers. Like, would you regex? How would you even do that? There's a part of me that wonders if you could make a video game based on this. If I rewrite a code base at work with web components whenever JS is used, is that also job security? Yes. 100%. 100% that's job security. You should absolutely be doing that. There's no reason why you shouldn't be doing that. Like a Zachtronic style game? Yeah, like a Zachtronic style game. Yeah. Like it would just, I don't know, there's something about this that might be fun to play in video game format. Absolute binary programs and rock type. Yeah, this would be absolute because it's a complete program. This would be rock type because something has to happen as a processing thing. niche. Yeah, it's niche, but it's fun. You doubt you would love it. You just you haven't had me make it. That's why. Okay, I gotta stop staring at this. This is like it's I'm sucked in.